Bismillahir Rahmanir Rahim. In the name of Allah, the most merciful and the beneficent. My name is Muhammad Vikasaza and this is my second lecture. Now going to the lecture, we will discuss applications of electrostatics, photocopier. So definition is such a machine that makes quickly and easily copies of a document. Its construction is selenium coated aluminum drum, toner, heated rollers. Its principle is the lamp transfer image of the page to the drum which leaves a static charge. The drum collects toner dust and transfer it to the paper. The toner is melted on page. Now discussing diagram as well as the working of the photocopier. First of all, light is incident on a mirror which is reflected at an angle of a 90-degree and focused on a aluminium selenium coated drum with an angle of a 90-degree where an image is formed. This image leave tracers in the form of a toner dust on a drum and pass through a toner cartridge where a powder is filled and passed toward a paper and stamped on a paper. Then this paper passed through heat rollers to melt the tonered powder on a paper. Next one is a laser printer. The definition is laser printer work is due to the process called xerography. So principle, it works on the principle of an electrostatic as well as based on a xerography. Its construction is laser scanning unit, mirror, toner coated roller, photoreceptor, drum, charging electrode, corona wires. So first of all, what is xerography? Xerography means dry writing. It is a Greek Latin word. So now diagram as well as working of a laser printer. A laser beam is incident on a drum with the help of a cylindrical lens and mirror. When this lens focused a light in the form of a laser beam on a charging electrode where an image is formed and printed because of an electrostatic principle and rolled down toward a heat roller. But first of all, it's stamped on a paper and then this paper passed through a heat roller where this tonered dry ink is melted and dry writing process is become possible. Now talking about the next application of electrostatics, this is an inkjet printer. Basically inkjet printer is a daisy wheel printer. It uses nozzle heads. Its construction is ink supply, pump, nozzle head, charging control, charged electrode, deflection plates, ink gutter and the paper. It works on the principle of an electrostatics. So first of all, ink is supplied to the pump and the pump supplied this ink to the nozzle head where a pressure is built and a thin stream of ink is produced. Tiny droplets pass through charging electrodes and become charged. Then these droplets means charged droplets pass through deflection plates. If the deflection plates are on, then these droplets are deflected and dropped in a gutter. If not, then these droplets move toward a paper. Now moving toward next topic of electrostatics, which is electrical flux. Electrical flux is a Greek Latin word. Its definition is number of electrical lines passing through a cross-sectional area or a dot product of electrical field intensity and a cross-sectional area. Its formula is phi is equal to E dot A. So it's a dot product EA cos theta. If theta is equal to 90 degree or a 270 degree, then flux will be minimum is equal to 0. If theta is equal to 0 degree or a 180 degree, then theta will be maximum, means flux will be maximum. Figure A represent case B. Figure B represent case A and C. SI unit of electrical flux is Newton Coulomb inverse meter square. Here is important question, Gauss's law. Definition: the net electrical flux through a closed surface is equal to 1 over epsilon naught total charge enclosed in a closed surface. This figure shows electrical flux closed in a closed surface. We have to prove phi is equal to q or epsilon naught in a step number 3. So we use Fi is equal to E dot A. A is the area of a sphere, that is equal to 4 pi r square. For electrical field intensity, we use E is equal to 1 over 4 pi epsilon naught q or r square. By putting value of E and A, we get phi E is equal to q over E. Now we will discuss about the application of Gauss's law. The first one is the electric field intensity in a closed hollow sphere of a radius r. For this purpose, let us consider a hollow sphere of a radius r. Inside the sphere, we consider a Gaussian surface which is in a red circle with a radius r prime. So r is greater than r prime, means less than a sphere radius. So the electrical field intensity inside a Gaussian surface is equal to 0. For this purpose, if Q is equal to 0, then by putting these values in a Gauss's law, phi is equal to Q or epsilon naught, so the flux will become in a 0. But in another equation, phi is equal to E dot A. In this equation, it is represented that E can become a 0, but area cannot become a 0. Now in next slide we will deal with the electrical field intensity in a metallic sheet of infinite charges. For this purpose we consider an infinite sheet of charges. Charges are uniformly distributed on this sheet. The charge density is Q is equal to sigma A. Now calculating the total electrical flux on both sides. For this purpose we consider a Gaussian surface by passing a metallic rod in a sheet. So in first equation we calculate our total flux phi E is equal to EA plus EA is equal to 2EA. Then we get this 2EA in the form of equation A. Now applying a Gauss's law, that is phi is equal to Q over epsilon naught. So this become an equation A. Now putting the value of Q sigma A over epsilon naught, this become an equation C. Now comparing equation A and C, so here A and A will cut off and 2E is equal to sigma over epsilon naught, and 2 become an denominator, so E is equal to sigma over 2 epsilon naught. This is electrical field intensity in a metallic sheet of infinite charges. Now moving toward the next slide. This one is the last application of a Gauss's law. So we have to calculate an electric field intensity between two oppositely charged parallel plates. For this purpose, we consider or we take two oppositely charged plates and consider a Gaussian surface between these two plates and calculate flux on each side. We take conditions phi 1, phi 2, phi 3, phi 4. Phi 1 is equal to E dot A is equal to EA cos theta is equal to EA, because electrical field intensity and area are both in same direction. While phi 2, phi 3 and phi 4. Phi 3 is out of boundary, so it is equal to 0. But phi 2 and phi 4 are at an angle of 90 degrees. So there is an angle between E and A that is equal to 90 degrees. So that's why these values are 0. Now putting all these values and calculate total flux. Phi E is equal to phi 1 plus phi 2 plus phi 3 plus phi 4. That is equal to EA. Now applying Gauss's law, phi is equal to Q over epsilon naught. As I already told about, Q is equal to sigma A. So phi is equal to sigma A over epsilon naught. Now putting these values of equation C and as well as A, we get E is equal to sigma over epsilon naught. This is electrical field intensity between two oppositely charged parallel plates, especially in case of a capacitor. At last, thank you. Assalamu alaikum. Pray for myself as well as for your family and for your friends. Assalamu alaikum, and thank you again for listening me and getting concepts related to electrostatics.